This is Audiovisual Lecture 9, Part 3. The last thing we're going to do is a sample problem for landing distance, taking into account a couple of those notes. So the situation is the temperature is 5 degrees Celsius. We're at gross weight, 2,400 pounds. We're landing on a runway with an altitude above sea level of 2,000 feet. The wind is blowing straight down the runway at 9 knots, and this is a grass runway. So we're going to determine, first of all, what our ground roll is. In other words, what's the distance on the ground that we need to stop the airplane, and what is the 50-foot obstacle number. So how much total distance do we need to descend over a 50-foot obstacle, land, and still stop in the given distance. We're also going to take into account those factors of the 9-knot headwind and that it is a grass runway. So first of all, you can see we have a number for 0 degrees Celsius and 10 degrees Celsius. So the first thing we're going to do is find both of these numbers and then split the difference to interpolate it. So at 0 degrees, so we have to first calculate 0 degrees at an altitude of 2,000 feet. At gross rate and 0 degrees is going to be 550 feet right here. Our over 50-foot obstacle is going to be 1,295. If we come over a column to 10 degrees, that increases to 570 for our ground roll and 1,330 for our 50-foot obstacle. So splitting the difference, we come up with a ground roll of 560 and a 50-foot obstacle of 1,313 feet. Now, to take into account the wind and the grass runway now, so we can decrease our distance 10% for each 9 knots of headwind. Isn't that a nice round number? We just happen to have 9 knots of headwind. So we're going to take 10% off of those numbers that we just calculated. So we have a 560-foot ground roll. That becomes 504 feet because 560 minus 56 is 504. And 1,313 feet for our 50-foot obstacle minus 131 is 1,182. So with the wind factored into it, our new numbers are 504 and 1,182. Now we're going to take it one step further and look at the grass runway. Now the notes. Note number 3 says for operation on a dry grass runway, we must increase our distance by 45%, only though of the ground roll figure. Now here's where it gets a little bit tricky, and you just have to think through this nice and slow. Or maybe you're a real quick thinker and you don't have to do that. But so if our ground roll number we know is 504 feet, that one's pretty simple. To just multiply that by 1.45 to add that 45%, that gives us 730 feet of ground roll. So as soon as the wheels touch the ground, we're going to need, here again, theoretically, 730 feet to stop the airplane on this grass runway with 9 knots of wind blowing against us. But now for the 50-foot obstacle, a part of that number is floating down through the air over the obstacle. We're not actually on the ground, and we don't have to add that penalty for that amount of time and distance that we're floating over our obstacle through the air. So our 50-foot obstacle number is 1,182, right? If we subtract 504 out of that number, that gives us the distance that we're using up for the obstacle, and the remainder is all that we have to add to that 730. So if we just multiply 1,182 by 1.45, that's going to give us a higher number than necessary because we're adding the grass runway component to floating over the obstacle as well, when in fact all we have to do is add it to that the time that we're on the grass. So we're going to subtract 504 from 1,182, and that gives us the time, the distance that we don't have to multiply by. And so 1,182 minus 504, the result of that number we add to 730, and that gives us 1,408 for our 50-foot obstacle. So again, what we did there, we calculated the condition for 0 degrees Celsius, also for 10 degrees Celsius. We took the difference, we split it evenly to get 5 degrees Celsius. We then factored the wind into that by decreasing both of those numbers by 10%. And then we determined the ground roll number by multiplying the ground roll number by 1.45 to add 45% to it. To figure out the 50-foot obstacle, we subtracted 504 from 1182, so our ground roll from our 50-foot obstacle number, and the distance we added to that 730, or the ground roll number on the grass. So just think through it as you do it. It's a fairly logical thing. So if you think through it carefully and just determine what you're trying to do, the number should come out about right. Okay, well that's all we're going to do with it for this lecture. This is just to introduce you to those calculations. There'll be homework like before for the quiz, and next week is going to be our last lecture. So we're going to go through a couple more of these problems and just do a very light review because that'll be our last lecture before the final exam. One other note, we only have 3 weeks of class left this week, next week, and then 1 more week for the final exam. You can take the final at any time in that period. But it also means there's only 3 weeks left to complete the project for the semester. So if you should be kind of into your, you should at least know the topics that you're presenting and have done a little bit of research on them. I'm happy to review any work in any stage. If you've just come up with a couple of sources, I'll be happy to review those. If you have a final draft, I'll be happy to review that as well. But the whole idea is to just give you several opportunities to present your work and have, I'll be happy to go over it and offer you feedback pretty much right up until your final draft. So just a reminder for that to make sure that that's well underway. If you have any questions about these performance calculations, let me know and we'll work through it. But the homework will be fairly straightforward. This question that we just went over will be on the quiz so that you can work through it by yourself and go through it on the lecture as well at the same time, just to help you make sense of it. So that's all for Lecture 9 on aircraft performance.